Good day to all of you. Today we shall study about Dijkstra's algorithm. Let us start the session. Dijkstra's algorithm is used to find the shortest distance from a given source node to all other nodes in a weighted graph. As the source node is the starting point, its distance is initialized to 0. From there we iteratively pick the unprocessed node with the minimum distance from the source. This is where a min heap or a set is typically used for efficiency. For each picked node I, we update the distance to its neighbors j using the formula distance of j is equal to distance of I plus weight from I to j, but only if this new path offers a shorter distance than the current known one. This process continues until all the nodes have been processed. Dijkstra's algorithm is not suitable when the graph consists of negative edges. In that case, Bellman-Ford algorithm can be used. So as a summary, what we can say that given a weighted graph, to find shortest distance and shortest path, Dijkstra's algorithm can be used. It is useful only when the weights are of positive values. So it is not suitable when the graph consists of negative edges, means when the weights are negative. So if the weights are negative, then instead of Dijkstra's algorithm, we can use Bellman-Ford algorithm. Okay. Next we shall see to a problem and how using Dijkstra's algorithm from a source node in that graph, how we can find the shortest distance to all other nodes, that is first point, and then shortest paths. Okay. The problem statement is find the single source shortest paths for the given graph by considering A as source vertex using Dijkstra's algorithm. So this is the given graph. This has 5 vertices A, B, C, D, E. A is the source vertex. From here to B, what is the shortest path? And for C, D and E. So these are the other nodes. So from source vertex A to these nodes we have to find the shortest paths. There can be two kind of questions in such problems. The first one is find shortest paths from source node to other nodes, that is first one. Second one, find the shortest distances. Okay, we'll solve for both. Here in the graph, these numbers which are written on the edges, they are the costs. So 10 is the cost, means it may be the distance or time or cost in terms of rupees. So the shortest distance here which costs less. For example, from A vertex to B vertex or from A node to B node, here the cost is 10. So the distance may be 10 kilometers or the cost in rupees may be 10 lakhs in constructing the road between A to B. So then there is one more path. We can move from A to C. The cost is say 5 lakhs. C to B 3 lakhs. So 5 plus 3 it will be 8. But from A to B if you move directly the cost is 10 lakhs. Which is smaller? So going from A to C, C to B, which costs only 8 lakhs, that is cheaper. It has less cost. Hence the shortest distance is from A to B is 8, not 10. Okay. Then the shortest path is A to C, C to B. So the shortest path for A to B is A to C, then C to B, which costs only 8 instead of 10 lakhs. Okay. So what we did, we found the shortest distance between A and B and we found the shortest path between A and B. So this way we have to find from source vertex A what is the shortest between A and other nodes and shortest path between A and other nodes. That is what is asked in this problem. That we have to do using Dijkstra's algorithm. So there are different algorithms. For positive weights, Dijkstra's algorithm can be used. If the weights are negative, we'll have to go for Bellman-Ford algorithm instead of Dijkstra's. Okay. Now we'll solve for shortest distances and shortest paths from source vertex to other nodes using Dijkstra's algorithm. Okay. First we have to draw this table. In this we'll have to fill all the vertices. Here the vertices are A, B, C, D, E. They are filled as column names in this table here. Since A is taken as the source vertex, so A to A the distance will be 0. That is what is taken here. But for other nodes at starting it is taken as infinity. So we had to start from A vertex. So for A vertex 0 is taken because from A to A the distance is 0. Now for other vertices they are marked as infinity. Okay. So now among all these distances, which is the minimum? 0 is the minimum. It pertains to which node? A node. Hence we will mark this 0 and mark A in the graph. So because 0 is minimum, that is marked with blue color here. Because it pertains to A node, that is underlined with blue color. So when A node is marked in the graph, we will have to include it in visited node list. So A is written here means node A is added in the visited node list. Because one step is completed with respect to A node, so that is this line is fully drawn here. Means the procedure with respect to A is over. A is included in the visited nodes list. Okay. Next we'll take this algorithmic steps, that is Dijkstra algorithmic steps, to find the shortest distances of other nodes with respect to vertex A. Now we'll apply these steps for node A and fill these spaces in the next line and enter the next node in the visited node list. Okay. So here we have filled. How we filled this? Let us see. So for node A, the neighboring nodes are B and C. They are connected through this arrow going out from A to those nodes. But E node is also connected through an edge, but that arrow line is coming to A, not to E. Hence, E cannot be considered as neighboring node. Only B and C are to be considered and their values are filled here. That is distance of B from A, distance of C from A. They are what are filled here. So how these values we get? Let us see now. So if A is I, first its neighboring node that B is J. Let us take it as J. So D of I plus cost of Ij. D of I means D of A, that is 0. Cost of Ij. Cost from I to J, that is this 10. So 0 plus 10. 0 plus 10 is equal to 10. Is it less than D of J? So D of J means D of B, that is infinity. So this 10 is less than infinity. So this is true. Then D of J. D of J means this D of B, that infinity, that must be updated. That must be equal to D of I, that is 0. D of A it is, plus cost from I to J, that is 10. So that will be equal to 10. So D of J must be removed from infinity and that must be given the value 10. And that value 10 is added here in the table under B. So A to B distance is 10. Similarly, A to C distance we have to find how it is equal to 5. Okay. A is I, C is J now. So D of I, that is A, that is equal to 0 plus C of Ij. From I to J, this is the connecting edge. Its cost is 5. So 0 plus 5, that is 5. Is it less? So is it less than d of j? D of c is infinity. So 5 is less than infinity. So this is true. Hence d of j has to be updated. So d of j means this is infinity. This should be striked off. It should be updated means d of I is 0 plus cost of ij was 5. This comes out to be 5. So this distance of c must be updated with 5. So distance from A to C, that is 5. That is what is updated here. This is how this line is filled. Next, among these two, which is the minimum? So 5 is the minimum. So 5 is marked blue here. It is with respect to C. Hence in the graph also C is marked with blue. C is added to visited node list. Then see that the step is over. Okay. So whatever steps we followed for A according to these lines of algorithm, that we have to repeat for C node now. Now what is the status of solution so far? A and C are the nodes that are added to visited nodes list. Hence A and C nodes are marked in the graph. And distance of A with A is 0. Distance of C with A is, see to the table which is marked with blue, that is 5. So this infinity is striked off and distance of C with A is 5. One more point, distance of B with respect to A, at present it is 10. So infinity was striked off, it was marked with 10. So this is the status of solution so far. So to repeat these lines of algorithm for C now, like how we followed for A, we'll simplify the steps so that understanding becomes easy. We can easily remember what should be done and continue it fast. Okay. So what we had done, A is the picked node. Its neighboring nodes are B and C. Distance of B is distance of A plus connecting weight 0 plus 10, that is less than present weight of B, and hence it is to be updated with 10, that is entered here. The neighbor of A is C. Distance of C is distance of A plus connecting weight. So distance of A is 0 plus this connecting weight 5 will be 5. That 5 is less than this current distance of C. Hence this to be updated with 5, and that is what is written here. Then these two are compared, which is minimum, that is underlined. It is with respect to C, and hence C is marked here. C is added to visited node list, and that procedure under C is marked as completed. So these are the steps that we have done for A, and those we have to repeat for C now. So for C node, B is the neighboring node. So distance of B is distance of C plus connecting weight. Distance of C is 5. 5 plus 3 is 8. 8 is less than this infinity. Hence it should be updated with 8. So that is what is written here. Next for C, another neighboring node is D. So distance of D is distance of C. So distance of C is 5 plus connecting weight is 9. So 5 plus 9 is 14. 14 is less than this infinity. Hence it should be struck off, and distance of D is 14. That is what is entered in the table here under D. Next again for C, another neighbor is E. So distance of E is distance of C plus connecting weight. Distance of C is 5 if you take from table, plus connecting weight is 2. So 5 plus 2 is 7. 7 is less than this infinity, and hence it should be updated with 7, and that is what is entered in the table here under E. Now for C node, its neighboring node distances are filled in the next line here. The minimum among these is 7, that is marked, and that node E is marked in the graph. So 7 is marked blue here because it is minimum in this line. It is with respect to E, hence E node is marked with blue in the graph here. Then E is added here in the visited node list, and a line is drawn under E to indicate that procedure with C is completed. What is the solution so far? A, C, E are in the visited node list. A, C, E are marked in the graph. So distance of A to A is 0. Distance of A to C is 5. Distance of A to E is 7. And at present A to B distance is updated from 10 to 8, and that of D is 14. So D. Now we have to follow these lines of algorithm for E node. So E is the picked node now. So in next line we have filled the distances of its neighboring nodes. So for E node, the neighboring node is D and one more is A. Because A is already covered, we will not consider this, we will consider only D. So distance of D is distance of E plus connecting weight 6. So distance of E is 7. So 7 plus connecting weight, this 6 is equal to 13. So distance of D is updated from 14 to 13, and that of B is continued to be 8 because this E is not connected to B. Whatever its previous status was there, that is continued here. Among these two, 8 is the minimum. It is with respect to B. So B is marked here. B is added to visited node list, and a line is drawn under B here to indicate that step is over. Okay. Now picked node is B. In next line its neighboring nodes distances will be filled. So for B, the neighboring node is D. So distance of D is distance of B plus connecting weight. So distance of B is 8. So 8 plus 1, that is 9, and this 9 is less than 13 and it is filled here, and it is the minimum, that is with respect to D. So D is marked in the graph. D is added to visited node list. When D is added to visited nodes list, a line is drawn under D to indicate that the procedure is over with respect to that step. Now if you observe the visited node list, all the 5 nodes of the graph are added. So the procedure of calculating the distances of other nodes with source vertex A and filling the table is over. Now we can answer one question of the problem statement. What are the shortest distances of other nodes with respect to source vertex or node A? So the distance of A from A is 0. Distance of B from A is 8. Distance of C from A is 5. Distance of D from A is 9. Distance of E from A is 7. So that completes the solution for first half of the problem. That is calculating the shortest distances of all other nodes from source vertex A. So that we can directly get from table here. Okay. Next we shall learn how to calculate shortest paths from single source node, that is A. So the one I will show, that is from A to D. So from A to D, shortest distance which we have already calculated, that is 9. For that, how to find out the shortest path I will show you now. The remaining, that is from A to B, A to C, A to E, what are the shortest path you will do, and put your answer in the comment box that I can reply. Okay. So now we will learn how to find the shortest path from A to D using this prepared table. For that we'll have to start from D. So D distance is 9, that is marked in the table. So we'll move to previous line. So there it is 13, because 13 is different, which is minimum. We go to that 8. Then we move to that 8 is with respect to B. We will record along with D here. Next we'll move to previous line. It is same. So we will not change B. We'll go to previous line. 8 is changed to 10. Hence we'll go to the minimum there, that is C. C we will record here. So we'll go to previous line. Infinity is there for C. It is changed now. So we'll go to the minimum, that is 0. So it is with respect to A. We will mark A here. We will write this in reverse order. So A, C, B, D. So it is the shortest path from A to D. So A to C is connected, C to B is connected, B to D is connected according to the found out shortest path, that is ACBD. So cross verification if you do for A to D distance. So we'll take A to C weight, that is 5, then C to B, that is 3, then B to D, that is 1. So 5 plus 3 plus 1, it is 9. So this is calculated now. Actually it was found from the table 9. So that is same as according to shortest path. So that completes the solution. Okay. So here the procedure for calculating the shortest path between A to D is explained. So you do on your own according to this procedure. Dot. What is the shortest path between A to B, A to C, A to E? 3 calculations you will have to do. That if you put into the comment box, I can reply to the answers. I hope you understood. Thank you.